Okay, Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Thanks for joining this session. During this session, inshallah, 5 papers will be presented. The first paper will be presented, inshallah, by Miss Alia Yahya Salim. This paper is entitled as Empirical Analysis for Arabic Target Dependent Sentiment Classification using Large Language Models. If you have any question, of course, you can ask during the discussion. Each paper will be presented within 15 minutes, followed by 5 minutes as question answers. Ms. Alia, could you please introduce yourselves and then present the presentation? The floor is yours.
السلام عليكم. صوت واضح؟
وعليكم السلام ورحمة الله وبركاته. مظبوط تفضل.
Hello everyone. My name is Ali Al Salim, a senior computer science student at Najran University. I have a strong interest in artificial intelligence, especially in the field of natural language processing. And that's it.
Please share the screen and present your work. The floor is yours.
Okay. Today, I'm pleased to introduce the second author of this paper, Dr. Shadia Abdalfa, from the S2-A KFUBM Joint Research Center for Artificial Intelligence, King Fahd University of Petroleum and Minerals, where we also conducting this research. The title of our research is Empirical Analysis for Arabic Target Dependent Sentiment Classification using Large Language Models. And the goal of this study is to utilize advanced models for accurately analyzing the sentiment of Arabic text, particularly focusing on sentiments directed at specific targets. Before we dive into the details, let me give you a quick overview of what I will discuss in this presentation. First, we will review the existing literature to understand the theoretical foundation of our work. Then I will present the background and significance of the topic, followed by the research problem we are addressing and the objective of the study. And after that, I will outline the methodology used in developing the model, and we will discuss experimental setup and experimental results, acknowledgement, and then we finally conclusion. In our literature review, we compare two types of sentiment analysis: independent analysis and target independent analysis. Independent analysis focuses on comprehensively understanding the text and evaluating its overall sentiments. In contrast, target-dependent analysis provides a deeper level of analysis by identifying sentiments directed at specific entities within the text. This type of analysis is important because it offers a more precise understanding of how individuals express their feelings towards specific topics, especially in texts like tweets that address multiple subjects. We noticed a lack of contribution in this area using LLMs techniques, particularly in the Arabic language, which motivated us to begin this research. And before we delve into the details of the analysis, it's important to explain the concept of natural language processing. This field is a branch of artificial intelligence that aims to enable computers to understand and interpret human language in ways similar to humans. Common tasks in this field include text analysis, where we analyze the content of the text to extract information, and sentiment classification to determine whether sentiments are positive, negative, or neutral. The field also encompasses tasks such as machine translation and speech recognition. All these tasks play a vital role in enhancing the capabilities of automated system in handling language. What are the challenges in Arabic sentiment analysis? Sentiment analysis in the Arabic language faces unique challenges. First, there are a significant linguistic complexity due to the diversity of dialects and the difference in grammatical and morpho- morphological structures between modern standard Arabic and colloquial dialects. Second, the available resources, such as annotated database, are limited compared to other languages like English. Third, there is a challenge related to the language of social media, where language is used informally and filled with appropriation and samples. Finally, understanding context and differentiation between sentiments directed at different targets within the same text require a deep knowledge of cultural and contextual expression. So, what the difference between these two types of analysis? Independent analysis evaluates the text as a whole and provides an overall sentiment classification without considering any specific entities within it. For example, when reading an article or tweets, the general impression is assessed without identifying if there are specific feeling towards a particular entity, such as a company or a person. In contrast, target-dependent analysis identifies the entities or topic in the text and evaluates the sentiments related to them individually. This type of analysis can be more complex, but it offers greater accuracy in understanding the diverse sentiments within the same text. And this is example of sentiment analysis with target dependent. The research problem we are trying to address involves identifying and understanding sentiment directed at specific targets within complex text. In texts that contain multiple topics, it can be challenging to accurately grasp the sentiments associated with each topic. This problem is particularly important in Arabic texts, which may include devices and complex expressions that require careful interpretation to uncover the sentiments. To conduct the research, we followed a clear methodology that includes the following steps. One, data split. We divide the data into a training part that contains 10% of the validation set, while the other part was allocated for testing. And then model training. We used few shot and set fit techniques, which fall under the category of fine tuning. Then we model testing. After that, we used the test sets for zero-shot classification, as well as to evaluate the model that was previously trained using fine-tuning. And then we recorded the results obtained from this process. And now I will explain what's experimental setup in our research. The S2-A datasets was collected to eat targeted sentiment analysis in Arabic, consisting of 3,000 tweets from Platform X, formerly Twitter, to represent various Arabic dialects, both formal and colloquial. It supports open domain sentiment analysis using AI techniques and includes columns for tweets, text, targeted entities, and sentiment classification, positive, negative, and neutral. Pre-processing setup, such as removing links and sensitive information, were implemented to ensure data quality and privacy. The dataset shows that 37.3% of tweets are classified as positive, 34.7% as neutral, and 28% as negative. And this is a sample of datasets. We have 3 columns: target and sentiment and tweet text. We used a variety of models to analyze the data, including GPT, Parrot, and Llama, each of which has different characteristics in understanding language and analyzing text. And this is prompt engineering, refers to the process crafting effective prompts for language models to generate desired outputs. The table in the image shows different types of prompt engineers techniques used with LLMs, including zero-shot target independent. The prompt asks the models to platform sentiment classification on a given sentence without specifically any target entities. Then zero-shot target dependent. The prompt asks the model to perform sentiment classification on a given sentence with a specified topic or a target entity. Then few-shot target independent. Target prompt provides a few examples for the models learn sentiment classification on sentiments without targeting specific entities. And finally, few-shot target dependent. The prompt provides a few examples for the models to learn sentiment classification on sentence with specified topics or target entities. This table compares 3 main techniques.
Miss Alia, excuse me, sorry for interrupting you, but please be informed that you have only 2 minutes to complete the presentation.
Okay. We have now compared zero-shot classification and few-shot learning and fine-tuning by data tuning, speeds, complexity, flexibility, and performance. And this is experimental results. The results in the target-independent sentiment analysis were significantly better compared to the results in target-dependent sentiment analysis. Subsequently, when testing the model on the test data, an improvement was observed in the performance of the target-dependent analysis, but the target-independent analysis still remains superior. Afterward, a fine-tuning process was carried out using the sets-fits techniques, which showed a clear improvement in the performance of both types of sentiment analysis. And the final results was the target-dependent analysis become slightly better than the target-independent analysis. And here we summary of the comparison framework, Marpert zero-shot, and then with whole data set, and here with test set, and here with fine-tuning, and then in target-dependent performance comparison. Acknowledgement, the other Before concluding, the others greatly appreciate the support of undergraduate research office at King Fahd University of Petroleum and Minerals for the KFUPM Summer Research Program. We also acknowledge the S2-A KFUPM Joint Research Center for Artificial Intelligence for providing the tools, environment, and guidance that were essential to the success of this project. Conclusion, in this study, we utilized LLMs trained on the ATODTSA datasets to evaluate Arabic target dependent sentiment categorization. Our initial experiments revealed significant improvements in accuracy and F1 scores for both target independent and target dependent classification. Despite these positive results, we aim to enhance performance further by expanding the datasets and refining our methods to better address dialects variation. Future work will explore fine-tuning for aspects-based sentiment analysis using set fits, as well as more advanced techniques like LoRa and XLoRa. Ultimately, our goal is to advance sentiment analysis research and deepen our understanding of public sentiment in the Arabic context. Thank you for your attention. I look forward to your questions and inquiries.
Thanks, Ms. Alia. We have actually 4 minutes for questions. Please, if you have any question, raise your hand and I'll give a permission for you to speak immediately. Do you have any question? Okay, let we move to the next presentation. The title for the next presentation is an innovative fake news detection in social media with an effective attention-focused transform Slimebell network. The presenter for this work is Dr. Rashmi Rain. Dr. Rashmi is a PhD student in machine learning at SAFMA University in Kenya. She has 22 years of teaching experience. She has various national and international publications. Her research interest includes social data mining and deep learning. Dr. Rashmi, the floor is yours.
Good afternoon, respected chair and the other researchers in this meeting. Should I share my screen, sir?
Yes, please.
Yeah. Hope my screen is visible.
Yes, it's visible now.
Yeah. Can I start, sir?
Yes, of course.
Yeah. Okay. So the title of my research paper is an innovative fake news detection in social media with an efficient attention-focused transformer slimmable network. Along with myself, Rashmi Rani, Dr. Subhashini R and Dr. Surendran R are the co-authors of this paper. This is the agenda for today's presentation. First, a brief introduction to the topic, the problems with the fake news, the proposed methodology, the details of the data sets used, the data pre-processing, which is done using self-guiding filtering, the feature extraction using multi-layer edge attention attention with focused transformer. The actual fake news detection using network slimming and optimization, the result and analysis, conclusion and references. So fake news are rapidly disseminating in the social media, as the use of social media is very enhanced. And users use Twitter, Facebook, and Bebo, and information passes at a very fast pace from one person to another person. So this paper introduces a self-guided edge attention focused transformer slimmable network, which is improved by Osprey optimization for the purpose of identifying fake news. The proposed model has achieved a 99.21% accuracy, 99.15% precision, and 99.12% F1 score based on the experimental data which we have performed. Certain problems with fake news. The social media platforms facilitate the rapid spreading or the dissemination of the information, which includes true news as well as fake news. The fake news are normally used to manipulate the public opinion, maybe for monetary gains or for political gains. The stock market values are also dependent on these, like they do get manipulated due to these fake news. The people who propagate fake news, they do it in high traffic, which results in a very low quality of contents and the facts are distorted. Fake news goes through a misinformation cycle, which has different phases like the consumption phase, the dissemination phase, and the production cycle phase. The proposed methodology which we have used in our research consists of gathering data from two data sets called as the Gossip Cop data set and the PolitiFact data set, which is a collection of news from the political background and from the entertainment industry. This data set has news articles, which has two types of data, text data as well as the image data. The first step of pre-processing comprises of pre-processing of text data using the normal NLP stemming process. The image data is pre-processed using a method called as the self-guided filtering. This pre-processed data is then fed to the feature extraction module. The feature extraction is done using multi-layer edge attention with focused transformer. After the features are extracted, then the actual fake news detection is done. For doing this fake news detection, slimmable pruned neural network is used, and hyper tuning of the features is done using the Osprey optimization algorithm. And then the performance metrics are calculated as the accuracy, the precision, the recall, and the F1 score. These are the details of the data sets used. The Gossip Cop dataset has around 20,000 total samples. The PolitiFact dataset has about 875 total samples. Our data is divided into a ratio of 70% is to 30% for training samples and testing samples. First, the data processing, which is done using the self-guided filtering. So the textual data processing, we use the normal NLP techniques in which first the tokenization of the data is done, then the stemming part is done, and then the stop word removal is done. The image data is the self-guided image filter is used to enhance the quality of the images. It adjusts an image feature using the image itself as a guide. So that is the self-guided filtering. Next part is the feature extraction, which is done using the multi-layer edge attention with focus transformer. Here, there are 4 major steps for the feature extraction. So the first step is feature encoder. Here, to efficiently collect and normalize the complex features, the feature encoder starts the process with a 3x3 convolution and uses the ReLU and the batch normalization activation functions. The second step is the feature decoder. Different convolutions are used to process the low level and the high level features. A sigmoid activation function is used to define the weights used in the weighted addition that merges the output from the 2 branches of the high level and low level features. The third phase of the feature extraction is the edge module. By using the extracted features from the feature encoder blocks, edge attention maps are produced during the edge feature extraction procedure. Lastly, the focus transformer approach enhances the memory efficiency by allocating power to the most relevant patches of the edge modules. Now the fake news detection using the slimmable network. So the slimmable network configures several subnetworks into adaptable computations path in fake news prediction. The dynamic selection of specific channel ratios to be used in each layer determines the configuration of each subnetwork. Network slimming is a method that reduces the number of channels by concentrating on the lower absolute values of the weight parameters within the batch normalization layer. The aim of this approach is to decrease the overall size of the network while maintaining its performance levels. The final part is after the fake news have been predicted, the hyperparameter tuning is done using the Osprey optimization algorithm, which minimizes the problem of high training complexity of the proposed method. The Osprey optimization again is inspired by the natural phenomena of a osprey or a sea hawk, the way it attacks its prey. The hunting process, the natural process of hunting is the inspiration for this algorithm. The first phase is initialization. Here, the ospreys are initialized at random positions throughout the search space. The fitness evaluation in the fitness evaluation phase, the proposed network model's accuracy performance is evaluated at each iteration by the fitness function. In the exploration stage, the osprey changes its position according to the availability of the prey. The new position at each iteration is determined in this exploration stage. The last and the final stage is the exploitation stage. So here the osprey selects the safest location to consume the prey during the exploitation phase. So by doing the mathematical modeling of this osprey optimization algorithm, the hyper tuning of the parameters is done for the final results, to enhance the final results. So the proposed self-guided edge attention transformer slimmable network improved by Osprey optimization method was tested using the PolitiFact and GossipCop datasets, achieving high accuracy and precision. The analysis included the metrics like F1 score, recall, and error rate, and comparing the new method with the existing techniques like the TSNN, topological sequential neural network, the EcoFake-D, the active learning AL, and a LSTM-LF, that is long short-term memory Levy flight board. So the table on the left-hand side shows the matrix comparison of the Gossip Corp data set. So the overall comparison shows the lowest error rate of 0.013 for our proposed method and the highest accuracy of 99.21 for our proposed method. The right-hand side table shows the metric comparison of the PolityFact data set. So here again, our proposed method is giving the lowest error rate of 0.015 and the highest accuracy of 99.19. The graphs show the accuracy and loss curve of Gossip dataset and PolityFact datasets. So after the 100 epochs, it was found that the data was the results were not changing. So we stopped at the 100 epoch. So in conclusion, the proposed method gives a robust and efficient method for fake news detection by leveraging advanced pre-processing, feature extraction, and optimization techniques. This method achieves high accuracy and precision, making it a valuable tool for combating fake news. So for future applications could include detecting COVID-19 related fake news using the same methodology. These are the references which have been used in the research. And thank you.
Thanks, Dr. Rashmi.
Yes, sir.
Actually, we have some time for questions. Please, if you have any question, you can ask, or first you can raise your hand. If you don't have permission to speak, please raise your hand. Okay. Actually, I didn't ask any question with the previous presentation since I am a co-author, but I have some questions for this presentation. Could you please go again to slide number 3, I think, to show the methodology again? Yes. As I understand, your work based on multi-model text and image. So there is a component here for applying maybe concatenation or merging for these two sources. Could you please describe how you applied the merging process? Plus component.
That plus component. This you're saying, sir. Plus
Yes.
component. Yeah. Okay. So the features were simply added, you can say, and both the multi-edge attention, like the feature extraction method merges the two pre-processed data. So that merging is done as the first phase of the feature extraction, the multi-layer edge attention transformer.
I mean, you firstly extracted features from text and image individually, then merged them as a late fusion, or you firstly applied here any methodology before extracting feature? This is my question.
No, sir. They were first pre-processed differently. Like the news article has some images also and some text also. So one component of the data set, suppose Gossip Corp, that has that news article will have certain text and certain image data. So these both will be pre-processed. For pre-processing of the text data, the NLP will be used. For pre-processing of the image data, the self-guided filtering will be used. These two will be merged before, will be merged and then given to the feature extraction.
Yeah, this is my question. How you merge both of them? This is my question. Do you mean that just put it as a single source? So as you know, when we talk about feeding data into the model, it should be as a numeric value. So of course, you extracted features to feed data or feed information as a numeric data, but this part is not clear. How you firstly merge them? You may mean that you firstly extracted features, then applied concatenation. For example, I don't know.
Yeah. So the integration of these two was done as the first, and then the data was given to the feature extraction. Integration is done, sir.
Okay, could you please go to the experiment results? Yes. When we talk about AL, what do you mean by AL? AL models.
Sir, that is the active learning model which was used in one of the paper in which I had done a literature review. So that
It's
was the
already available on paper.
so that method was used in a research paper which I've used as a reference. So they had used that methodology and that method we had applied on our data sets and compared.
Good. You applied your work your experiment work based on two data sets. As I understand, again, each data set includes images and text. I'm right?
Yes, sir.
Is correct? So of course it should be also labeled. And as I understand, it is a binary classification problem. Or you have
Sir,
multiple classes?
No, sir, just two classes. Whether
Binary
fake news
classification.
or no.
Okay, thank you. It seems we don't have more questions. So thanks again to Dr. Rashmi. We will move now to the next presentation. The next paper entitled as Unmasked Harmful Comments, an approach to text doxinic classification using machine learning in native language. The presenter is Miss Afia Al-Hassan. She is a master student in the Department of Computer Science and Engineering at East-West University, and she also serves as a lecturer in the Department of Mechanical and Production Engineering at أحسن الله University of Science and Technology. Her research interests are deeply rooted in artificial intelligence, machine learning, and natural language processing. Miss Afia, please present your work. The floor is yours.
I'm sharing my slide.
Yes, please.
Is it visible, sir?
Yes, it is visible.
Okay. Hello, everyone. This is Afia Hassan. Today, I'm presenting paper ID 157-107-1658. Thank you for the organizer of the conference for giving me the opportunity to show my research work. A special gratitude to researcher Dr. Shadi Ibrahim Abu Dalfa from King Fahd University of Petroleum and Minerals. Today, I am presenting my research work named Unmasking Harmful Comment, an approach to text toxicity classification using machine learning in native language. Few months ago, I saw a news article in our Bangladesh from where I came to know that about half of the schoolgoers, especially 12 to 18 years old children of our country, have encountered cyberbullying. And surprisingly, this is not a scenario of our country only. It's happening all over the world. So it is very important to detect and remove the toxic comment from the online platforms to give our generation a healthy life. So for the research work, I have the table of contents which shows the topic that would be covered today. In the introduction part, at first, we need to know what is toxic comment actually, or which type of comments should be included in toxic comment. So from the definition, we know that the words or sentences which often includes hate speech, harassment, or personal attacks are usually called as toxic comments. There is a different level of toxicity in the comment. Some are very intensive and some are moderate. But the result of these toxic comments is deteriorating mental health of victims. Though the social platform trying to identify the harmful contents, it's still cumbersome because of multilingual environment and large amount of data in the social media platforms. To overcome the situation, we focused on social media comments classification using 3 machine learning models. They are stochastic gradient descent classifier, support vector machine, and optimized support vector machine that are our proposed model. The importance of artificial intelligence to foster safer online environment is highlighted here. The objectives of the research paper is to address the multilingual toxicity framework, introduce and optimize support vector machine using hyperparameter tuning to increase performance metrics. Here we use radial basis functional kernel to capture non-linear data patterns. The last objective is to compare the effectiveness of the base models and optimized model and select the best one. Before us, some other authors were also done research on comments classification from their study. Few studies are included here. The first one, the author integrated machine learning and deep learning, and the accuracy was very high, that is 94%. But they only take the language is English and they take news and comments from renowned papers. The next paper used transformer-based model only for Bangla comments and achieved 85% accuracy. The third paper also worked with Bangla comments with word embedding and accuracy was 83.66%. The last paper used only support vector machine on which have F1 score is 76.57%. There is a version of my dataset. I'm just including few comments that I used as my dataset. To do our research, the dataset was created and collected comment from different social media platforms such as Facebook, Instagram, etc. and also took help from a dataset of Kaggle. The total number of comment of my dataset is 9,061. There 4,538 comments are Bangla and rest of are in English. From the figure 1, it is very clear that the proportion of Bangla and English comments are quite equal. However, figure 2 and 3 shows the proportion of toxic and non-toxic comments of 2 different languages. And there is some difference in the proportion. As the dataset is ready, we started to pre-process so that we can apply the model with more efficiently. For our model implementation, firstly, the punctuation and such as comma, semicolon, colon are removed with other special characters. all the alphabets are converted to lowercase. Then we tokenize the sentences. For example, if the sentence is "you are beautiful," then "you are beautiful" are 3 tokens. Deleting stop words, converting the token into numeric value, which is called vectorization. Split the dataset for training and testing, and the percentage of training dataset is 70% and for testing it's 30%. Then try to understand the frequency of words and their weight with TF-IDF and what embedding is implemented. Here in the figure 4 illustrate is the model for the toxic comment classification. The diagram is very easy and understandable for everyone. We do data pre-processing, then split the data for testing and training and testing dataset are incorporated in base 2 models, that is stochastic gradient descent classifier and support vector machine, and then optimized support vector machine is also applied. Both the 3 models are used for predicting the accuracy of comments, and with the high accuracy model will be implemented to detect toxic comments. In the result section, we can see the accuracy and other performance metrics such as precision, recall, and F1 score. From the performance metrics, it is clearly visible that the result of optimized support vector machine is much more reliable than stochastic gradient descent classifier and baseline support vector machine. Findings of the result is stochastic gradient descent classifier less effective and support vector machine is showing biasness and struggled with class imbalanced. But on the other hand, optimized support vector machine effectively address class imbalance and context dependent toxicity. At the end of the research, we find that the study provides scalable solution for social media comments detection, helping automatically moderation of contents rather than manual operation, encourage a supportive online community, and address critical challenges such as handling imbalanced data sets and contents dependency. However, there is further opportunity for other researchers to do more about toxic comment classification. They can use our paper as a base for their research. Increasing recall can ensure better coverage of toxic comments. That's all from my side. If you have any queries, please let me know. Thank you all for your precious time and attention.
Thanks, Ms. Afia, for your presentation. Again, we have also some time to questions and answers. Again, if the audience have any question, please raise your hand. Okay, actually, I want to ask also another question regarding the dataset. Is it a collected dataset or publicly available dataset?
So there is a mixed of, I take a public dataset from Kaggle and I included some more dataset from Facebook comments.
You mean that you included another more samples from your language?
Yes.
Separately, individual. So we don't talk about the same text includes 2 languages.
Yes.
Regarding the optimized support vector machine, is it an existing model? You just downloaded it and used it immediately, or you applied the optimization with this work?
For optimized support vector machine, I use my own algorithms. There is I use radial basis kernel penalty parameters and kernel parameters to optimize the generalizations.
You mean you applied optimization for tuning the parameters. This is the idea.
Yes.
But regarding the specifications, what's, for example, the kernel used with this model? And as you know, there are many parameters. Is it available to show it here, or you can't now?
Do you want to see the code?
No, I don't talk about the code. I talk about the selected values of these parameters. Which values you use to show that this is the best values can be used to improve the performance.
So this is not included it here, but I use the parameters for different section, and I after tuning I got the best result is 87%.
When you try to apply this optimization, is it also as traditional way just to increment the values by specific step, or you applied different optimization algorithms to select which one is the best?
Sir, after this, regarding some research paper, I got this for parameter optimization. This model works best with support vector machine. So I try to apply these parameters only.
Thank you. Thanks again for your presentation. We will move now to the next paper, inshallah. The next work is entitled as Towards the Development of S2-A based big data model for adaptation in the HEI in Bahrain case study. It seems there are two presenters, Rula Al-Haddad and Shuruk Busaleh. Are both of them available here?
I am Rula Amir.
Your co-author, Shuruk, is also will share the presentation, or you just be the presenter?
I will be the presenter, but I don't know why she didn't join us.
Okay. Actually, I didn't see biodata for you. So please introduce yourself, and then you can present your work. The floor is yours.
Just a minute to share my screen.
Yes, of course.
You can see the screen.
Actually, no, it seems there is a problem with displaying the content. Could you please stop sharing and share it again?
Is it okay now?
Actually, same error. We see a message show that cannot display content.
Salam. It's okay for us. We can see it.
Really?
Yeah.
It seems a problem with me.
Yeah, I hear it
My
too.
computer maybe. Okay, go ahead.
Okay. Assalamu alaikum wa rahmatullahi wa barakatuh, everyone. I'm Rula Haddad. I work as a teacher in Jordan, in Ministry of Education for 20 years. And now, currently, I'm a PhD student in University of Bahrain, College of IT. I'm honored to present our study titled Towards the Development of an SOA-based Big Data Model for Adoption in Higher Education Institutions. Our presented agenda will be introduction, problem. I should see that I should present my colleague Wala Khlifat and Shuruq Al Jassim. This work collaborative with them and guidance from Dr. Ihab Al Udwan. Our agenda today will be presented: introduction, problem statement, previous work, aim, methodology, proposed model, and then conclusion. In the introduction, let's start with two main ideas behind our study: enterprise architecture, EA, and service-oriented architecture, which called SOA. Enterprise architecture actually is it's like a framework that helps guide an organization growth by aligning its goals, processes, and technology. In higher education, this means creating a unified plan that support both academic and administrative needs. SOA, on the other hand, or service-oriented architecture, is a designed approach that allows different systems to work together smoothly by using modular services that can be easily reused. For universities, this means they can adapt quickly, handle growth, and ensure their technology systems communicate well with each other. We can say together EA and SOA provide a solid foundation for institutions to move toward more connected and efficient digital environments. The problem statement here in our research focuses on a major gap in Bahraini higher education institutions. Many of these institutions actually don't have a standard framework or clear method to guide their digital transformation. As a result, using big data analytics in these institutions has been inconsistent and unstructured. This highlights the need for a cleared or standardized model to help higher education institutions adapt big data solutions effectively. In our literature review or previous work that we mentioned here, we review study and models that have explored big data analytics adoption and the use of service-oriented architecture in higher education. We can say, in short, the previous research provide useful insights, but lack a cohesive framework that can be widely applied in Bahraini education contents. As we can see in this table, most of them focus in traditional frameworks like TOGAF or maybe Zachman, or they are useful framework, but we need to use modern frameworks like SOA. The aim of this study is to propose a SOA BDAF, a model that integrates service-oriented and enterprise architecture to support big data management, streamlined analytics, and meaningful insights for both academic and administrative function. This framework aims to guide higher education institution from their current state, which we called it as is, to the target state, which we called it to be state. Our methodology here The development of S2-A is guided by employing design science research methodology, which called DSRM, and single holistic case study for higher education institution 01 with structured interviews for data collection and analysis. As we can see here, there is 6 phases for this methodology. The first one, problem identification and motivation, defining the solution, design and development, demonstration, evaluation, and communication. The first phase and the second phase, we mentioned it before, so I will transfer to the third phase to explore how we use this methodology in our research. In the third phase, we use this to design, in this phase, to design the S2-A as we can see, our model contains or consists from 2 main parts. The left section, which contains 3 primary architectural components. The first one is business architecture, focus in the business processes, strategic objective, and services within the institution. The second one, information system architecture, or ISA, deals with the information system that support data flow within the institution. The third one, TA, or technology architecture, concentrate on the technological infrastructure. Each of these components actually plays a role in aligning business goals with IT resources, ensuring that the institution's strategy is supported by effective technology. The right side from our model, the layered structure of services that integrate and manage data within the institution. The first layer, as we can see, the presentation layer, which gives easy access to information on different devices like through university portals. Then the business layer support key university tasks like admission, course sign up, and maybe financial help. The application layer add tools for data analysis like digital libraries. The resource layers, which provide special tools for big data like learning, tracking, or payment system. And the heart of this model, the core layer for data management, this layer focus on storing and organizing a large volume of data. Maybe, for example, databases for student records. And we can't forget the security services keeps data safe within control and data protection, and the governance ensures data meet university rules. And the backbone of this model, ESP, or Enterprise Service Bus, helps different systems communicate and share data. And the infrastructure services support data storage and processing for big data like databases and network services. The fourth phase here is the demonstration phase, and we collect data in this phase from a private university in Bahrain. We coded it HEI01 by interviewing members, especially IT employee. And this is a sample from a huge data that collecting in maybe more than 4 months later. In evaluation phase, we choose Delphi technique. This technique used to gather feedback from experts. Actually, we asked 10 experts in this evaluation with 2 rounds to have our result. Last, the conclusion, this study developed and presented a S2-A DAF, a comprehensive model designed especially for higher education institution. The research provides, inshallah, several significant contribution to the theoretical understanding and a practical implementation of big data analytics in higher education. Thank you for listening and for standing this time for me. Thank you.
Thanks for the presentation. Actually, I still didn't see the screen, but it seems it's close to theoretical background. So I don't know if there are questions in this presentation. Again, my question to the audience. If you have any question, please raise your hand. It seems we don't have questions for this presentation. Okay, let me move to the last presentation. This paper entitled as Hybrid Voting Ensemble Classifier for Software Defects Prediction. The presenter is Miss Fatma Abdel Latif Sheikh. She is a PhD student in Computing and Information Science at University of Bahrain. Her research interests include artificial intelligence, machine learning, and intelligent system. Ms. Fatma, please present your work. The floor is yours.
I think she is not here, as I see in the attendees.
She is
We
not
don't know.
available.
Yeah, she's not available, I think. She can hear us, she can raise her hand. But I
Actually, her presentation should be started after around 14 minutes. So it seems she didn't yet join us. Okay, let me please make, if you don't mind, of course, let me make a discussion with you regarding your work. Miss Rula, you hear me?
Yes, Doctor.
Actually, I'm not expert with your research direction, but I expect you propose an approach for improving the performance of this service, as I understand. So, do you use any artificial intelligence in this work just as a tool, or maybe it is a future work in your research direction?
Maybe in future work, but actually our research is related to information system. Enterprise architecture is planned IT or IT planner, plan tool. Inshallah, in future work, we will collaborate with as software engineer experts, our colleague in our department, and we can develop a platform for the bus that I mentioned.
Good. Do you mean that you will explore maybe performance of large language models in this direction? As you know, currently it's a trend to using large language models with education.
Maybe inshallah in the future.
Okay. Regarding the organization or the surface for this. As I understand also again, it is a description for an approach or maybe platform can be used to improve the performance of higher education institutes. Is it just for management, for employees and faculties, or it can be also used with students?
Actually, enterprise architecture is a comprehensive for all the organization. It aligns the business strategy with the technology architecture. So it's a comprehensive approach or analysis for the whole organization or in here in our case, a university.
MashaAllah. And I think you will maybe try to apply a demo, for example, or make a prototype to show the performance of this enterprise architecture, or it is already available currently.
Can you repeat or?
I mean to calculate the performance of this architecture. Do you work on build a demo, for example, or just as a description, theoretical description?
No. In this phase, we are in just architecture model. And our evaluation is just to take feedback from the expert, as I told in the presentation, with a technique called Delphi technique. After we get the evaluation, we will maybe take another case study to make it more validation. Then we will maybe make a demo.
You mean it's just a survey to receive a feedback from some experts?
Yes.
Good, mashallah. Regarding also the survey, is there specific requirements for collecting data from the experts, such as statistics, specific statistics, or just a general questions?
No, there are in the paper we will mention the structure question that we give for the expert, and Delphi technique. It's a technique contains four phases: the facilitator and the expert and the questionnaire, and it should be anonymous to prevent any bias in their opinion. And then we will take 2 rounds to have our results. And after that, we are in this phase now, in the first round. And my colleague Shuruq she is the facilitator of this technique, and she is in the second round now.
MashaAllah, good. Regarding the answers, it is a 5 scale values, or it's as a text summary or something like this?
No, it's a numeric value. You say you ask about the questionnaire.
I mean, when you receive the response from the expert
Yes.
for each question, is it a 5 scale, such as strong, agree?
Yes.
Like this?
Yes.
So
yes.
you receive this information after that.
And analyze.
You want, of course, to analyze it, but as I understand, you analyze it as a statistical approach. Are you also interested in apply some maybe machine learning techniques for also analyzing this data?
Actually, none of of us are interested in this field in machine learning. So we use SPSS statistics program.
Actually, I worked with my colleagues on this direction before some years. So there is a research called data clustering can be involved with this work to cluster groups firstly based on their behaviors. So it will be interested to, for example, receive general insights about the collected data, and after that you can check each group individually to see more details about the collected data. So if you try to explore this maybe direction, it will be maybe interested for you.
It will be good contribution maybe to explore our research.
Inshallah.
Inshallah.
Thanks for this discussion.
Thank you.
Actually, we should start the last one, but it seems again the presenter is not available. Again, the presenter is Miss Fatma Abdul Latif Sheikh. Are you available now? Miss Fatma, it seems it's not available also. This is the last presentation, and as I understand, she should be presented. And based on the announcement, she should be available before 5 minutes, the time of the presentation. And currently, we are on the time. So this presentation talk again about hybrid voting in sample classifier for software defects prediction. There are two co-authors, Mustafa Hamad and Qasim Ubaidat. If one of them are available, please raise your hand. It seems this work is related to software engineering. I prefer to wait 3 minutes, okay? After 3 minutes, we will close the session if we didn't see any of the authors for this article. Let we wait 3 minutes, please.
Doctor, we can't hear you.
Sorry. Thanks for clarifying this point. Okay, again, this is the last presentation in this session. This paper entitled as a hybrid voting ensemble classifier for software defects prediction. The presenter is Fatma Abdel Latif Sheikh. Please, if Fatma is available, please raise your hand. Miss Fatma Sheikh or Mustafa Hamdan. And also there is a third co-author, Qasim Ubaidat. It seems none of them are available. So in this case, we should close this session. Actually, I'm pleased to meet you in this session. I wish you the success in your, inshallah, future research. And I hope meet you, inshallah, in other meetings and other conferences. Thanks for attending this session. Thanks for answering the questions, and thanks for presenting your work. Assalamu alaikum wa rahmatullahi wa barakatuh.
Alaikum salam. Thank you, Doctor.
Bye-bye.